attempts were pretty good, but a lot of them could be better. And I'll give you an example of one that needs to be better. And if you're the one who drew this or you drew one similar to that, you know, don't be embarrassed that I show it. Doesn't show your name. Not a big deal that you got it incorrect. I just want you to go ahead and find out how you do it correctly. Now this one is really well done. Almost everything in it is correct. The only thing that's kind of not right is the logic of the if statements. So, you know, input output should always be done in the tilted boxes. So that's correct. Print, enter your name, input age. That's all very good. An if statement, if your age is less than 18, that's good. But this has got two else's hanging off of it. You know, it looks good. It's making a little symmetrical tree, but it's not right. And the reason why is you can't have two else's. You know, if this was, we need one way out of the if to be the true. And then at most, we need one line that's the else. So the flowchart we're going to draw is not nearly that pretty. You know, it's not all nicely balanced and stuff like that. Another thing that's good about this one is that every path winds up at the stop. A lot of people, if they drew the two trees like that, they just ended it, you know, the blocks here. They didn't have any lines going back here. And, you know, it's a map. It's a map to the end. Every path has to get to the end somehow. So it is also good in that respect. So let's see. For the other class, come on. I said. Here's the code that we're going to flowchart. And I could type it in, but we're going to save a few minutes. Although it always reinforces it, and it puts half the people to sleep when I sit here typing. Okay, so print. What sound does your pet make? It's going to ask that. S&D is equal to input. That copies whatever they type into the S&D variable. If sound is equal to bark, print dog. We guessed it's a dog. Else if sound is equal to meow, print cat. Else if sound is equal to moo, print cow. Really? And then finally a last else, which is I can't guess. And then print done and then stop. So we're going to do two flowcharts today, and this is one of them. Let me log into Lucidchart along with y'all. You can use Visio. If you've used Visio before and you don't want to use Lucidchart, that's also no big deal. We can do flowchart. And my flowcharts always wind up being really cramped because I'm trying to get as much on the screen at once. Every flowchart needs a start and a stop, or a function name up at the top and a return statement at the bottom if you're doing a function. So, start, and I'm going to make my boxes as small as possible and then zoom in. There we go. Okay. Now what's the first thing it does is ask, what sound does your pet make? That's a lot of writing. But anyways, we know what an input-output box looks like. I'm just going to draw a line straight down from there by touching that little bottom circle, or you can just drag it out from the box. Print, what sound does your pet make? And now the text is overlapping off the sides. That's okay. You know, it's not like we're making this for publication, but I'm just going to drag this out. Whoopsie. No, I'm not. I'm going to stretch this out a little bit so it doesn't look quite like that. And I'm going to use Control-Enter in certain places to try to make it fit better. Don't have to do that. You don't have to spend a lot of time trying to make it perfect. Now we need an input box. Input box just looks the same, you know. we could use this box for input. Lucidchart gives us this symbol, but instead we're going to follow the tradition of just using a parallelogram for input and output. And I'm going to type input S&D here. I could make it match exactly our Python code. S&D is equal to input. Either one works. Either one clearly communicates the idea that we're letting the user type in some input and we're storing it in a variable called S&D. Alrighty, now we have some if statements. I'm going to drag this to the middle because I feel a little bit crowded, and I usually make my else's go off to the left. So I'm going to drag a box around all three of these shapes and then just drag it to the middle of the screen so I have room to go off to the right and to the left. Alright, the first if statement. Let me remind myself the order in which we did these. Need help?
Oh, it sums up the font on it. Like, it's just black squares every time I try to type.
That's not cool at all. What's going on with that? Well, that's crazy. They let you type start. Firestorm.
Yeah.
Chrome or Drive, not because I think Chrome's better, but because I just want something different than what we were using last time.
I used Firefox last time.
Yeah, I have never seen it do that before. So I'm not really thinking it's the browser, I'm just changing it in hopes that it fixes it. So anybody else is doing something weird where when you type something in, you're getting little black boxes rather than... Nope.
Yep.
What browser are you using?
Firefox.
Switch to Chrome. I have no idea why it's doing that.
I mean, it seems fine, like it might load later.
Go ahead and save your document, file save, exit it, go into Chrome, and reload it. Does that make absolutely sure? But here it is working. Okay. Yeah, so if you're getting problems, it seems like Firefox isn't working. It's not because it's a bad browser. I use it all the time. I don't know why it's messing up for some of y'all. If it is, just launch Chrome. If Chrome isn't docked anywhere, just go to the search bar and run Chrome, like that. So save your document, go back into Chrome, log in again, open it, and it should be there. All right, our decision. I've already forgotten again what order we did. Oh yeah, bark, meow, and moo. Okay, so if sound equals quote, bark. I'm going to make my true side go off to the right. And I have kind of an else statement, but I'm not going to really do else. I guess I could, but I'm going to make it elif. So the true side is going to go over here and it's going to print something. I'll make it pretty later. Right now it's just going to say print dog. Make that box small. It doesn't need to occupy a Trump Tower size, spot on the screen. Okay. Now my personal preference is if I'm doing an elif to drop a box straight down, pick another decision block, and do elif. Now, strictly speaking, in flowcharting as it was invented, in the 1800s or whatever, even before computers, you didn't put if statements in these blocks. But I think it makes programming easier. I think that if we were going to write a program based on this code, then seeing these words if and elif, or if you're using another language, making it else if, makes it a lot easier to follow along. Okay. So elif sound is equal to meow. And I know some of y'all are behind because it was messing up, so I'm going to try to not rocket ahead. I'll spend a little bit of time reorganizing it, cleaning it up, so everybody gets a chance to get ahead, or match. Okay, and if it said meow, then the true side, and like I said, I always make true go off to the right. And the reason for that is simply because we indent our code under an if block, under an if statement. And when we indent, that pushes our code to the right. It's the same idea. You don't have to do that. You can make the boxes go to the upper left and, the lower right and, around to the other piece of paper or whatever, as long as they eventually wind up at a stop block. Okay, now this is looking bad because these lines end. Dog stops here, cat stops here. But that's not our final answer. Eventually we're going to make them go somewhere. Now I need one more elif. And these little curvy lines, I can correct them to make them straight lines and right angles and stuff like that, but I'm not going to do all that right now. Okay, another elif. I'm going to drag a line off my elif sound block, add one more, and this is for moo. Elif sound is equal to moo because we have a cow living under our bed. And if it says moo, then it prints cow. But we're kind of dubious about that, so I was going to put a question mark at the end of it rather than an exclamation mark. Print cow. Yes, sir.
Shouldn't the elif sound be cow?
Yeah, that's supposed to be moo. You're right. I don't know why I put meow twice. Thanks. Thank you very much. Now, I've kind of tilted these like this for a specific reason. It's not strictly necessary. But you'll see why in just a minute. Okay, so if it's not a moo, then if we look at the code again, it looks like this. It's got an else rather than an elif. In my own tradition, not strictly necessary, is to make the else's go off to the left rather than the right, and to actually put the word else rather than false or no. And again, this is kind of my variant of it. You don't have to follow it exactly, but I think that it makes programming from these charts very easy. So since I'm doing an else, it's going to go this way, and it's not going to a decision block. If it was going to a decision block, it'd be an else if. So instead of saying no, I could leave it no, if that's confusing, but I'm going to put the word else there just because I said I was going to, and it's going to print, I have no idea. I'm going to use Control-Enter to add a return right in the middle of that text so it's a little bit easier. All right, now we're almost done. I just need to have all this stuff connect back. I could have it connect at the bottom where it has a print done statement, or I could have a little circle where they all connect. Either is totally fine. You know, but in our code, this is what it looks like. Not that one. It's got print done. So if I'm not going to use a little circle for them to all hook up to, I'm just going to print. Go away. I'm going to add a IO box right underneath here. And it's going onto a second sheet of paper very soon. You know, I think. Yeah, I think doing that added a second sheet of paper to mine. That's no big deal, you know. It automatically expands your drawing space as you draw. Okay, and so this one is going to say print done. And all of these boxes need to wind back up here. And I kind of changed my mind. I really do want to put a little circle here, but you don't have to. This is called a connector. You can make it a little smaller. You can delete that letter that's inside it. And then just make all of these things that came out of the if, else, if statements hook up to it. And they may look kind of goofy as you do this. We can always move the lines around later. Or we can pick a theme that makes right angle lines. And then I'm going to add a done. So, or a stop, excuse me. A stop is another pill shape. There we go. I'm going to zoom out a little bit to try to get all this to fit on one page, and then I'm going to fix those lines that are crossing each other. You know, I say that it doesn't have to look perfect. However, lines that cross each other like that are a little too much. And for yours, it doesn't matter. You know, it can just, you know, it can be 20 pages long. It's totally cool. Because when you save it to a PDF, I'll just scroll up and down and see it. Now, if you want to change the shape of the line without choosing a different theme, we could choose a different theme. You know, just come up over here, choose a theme that's got right angles. That would make it look a lot better. Heck, maybe I'll do that. That's a real easy fix. I'm going to choose a theme with right angles. And then you can grab your lines if you take some care and fix them. Now this one's just flat out hooking up in the wrong place. Alright, I'm going to take a little bit of time to fix it to my preferred style, and then I'll wander around and make sure that y'all are doing okay. Sometimes you get really frustrated with a line, with a connector, and you just wind up having to delete it and redo it. Alrighty, I wish I could zoom in and still get the whole thing on one page, but I really can't, more than I've already done. That's what I consider a fairly well done flowchart. And what I mean by that is it represents accurately what I feel the logic of that code to be. And if you've already drawn the other flowchart, you know, the flowchart was very similar. You know, if your age was less than 18, it printed too young. Else, if your age was greater than, 99, it printed too old. And then else, it came off like that. All right, I hope that's clear. I hope that helps on the assignment that was already due. If I don't give you full credit on the flowchart, you can revise it and resubmit it. But I'm not going to count a lot off unless I think the logic is broken. And the place that the logic was most broken for most people who had problems with it was in the if-else-ifs. And I think I demonstrated if-else-ifs, but I didn't make you draw one with elifs. So, now we have. Anybody need any help? Behaving weirdly, behaving good?
No,
Sure. All right, people still need a little bit more time. I'm not going to rush y'all. I want this to be correct. If you were trying to fit all of this on one page because, you know, you were doing it to make a printed assignment or something, it's okay to have some of the stuff go back up here. Now, I'm not going to put any of this block of the if-else ifs up here, but, you know, this print statement and this stop statement could be dragged up here like that. And that's totally okay. As long as we have an arrow showing that, you know, we're going back up to the top. Now, don't change your drawing to fit that. I'm just saying that if you had to draw this and you were trying to fit it on one page, once you hit the bottom of the page, you could either draw an arrow going to a new page, you know, straight down or up to the side, or you can just, you know, if you still have room on your page, start back up at the top and then draw a line down from here going back up there. That's totally cool. Alrighty, I can't think of anything else to do to this one. I'm going to load up the document that I'd made and make sure that this kind of matches it. Yeah, here we go. This looks very similar to what we did, except it's colored. If you don't feel like putting the word ifs in your blocks, in your decision blocks, that's okay. If you don't feel like putting elifs in your blocks, that's okay. The logic can be inferred. I like doing all that because it matches the syntax of the language that we're learning. And even if the language you're using doesn't have elif, it does have else space if. So I think that that's a good match for a lot of languages to structure it like this. Alrighty, one more program we're going to do before we repeat our lecture. I need to upload that one into our notes. Oh, by the way, this hasn't happened much in this class, but it has happened in other classes. If you see a document in a folder that's got a $sign and a little squiggle in it, that's a temporary file that Microsoft Word has created. Look at the difference in the file sizes. This one's 175 kilobytes. The temporary file is only 1 kilobyte. 1 kilobyte is not enough to hold an entire document. Don't ever upload the file that has a $sign in the name. It becomes really clear if you just close Word completely. When Word closes completely, the $sign disappears. So it's not a bad idea to close Word before you upload your homework. And if you do upload a $sign, I'll ask $sign file, a temporary file, I'll ask you to go ahead and upload the correct one. You won't get credit for it though until you get the correct one uploaded, because I can't grade it. Okay, so this next assignment, and I think it'd actually be cool to type this one in, is going to be the good old guessing game that we did before. Except it's going to implement a function. We've talked about functions. We've talked about fruitful functions. And a function is going to ask for the favorite number. It's going to ask for input. It's going to convert it to an int, and then it's going to return that int. And the reason we're going to do that is because we can boil down, you know, like 3 statements there into a single statement. So I'm going to pop up an idle. File, new file. Save as. Don't save it in the Python directory. I'm going to call it guess2. Just because it's like a second or third iteration of our guessing game. I'm going to put my name up here. Alvin Programmer. Guessing game. And then the date. April 5. From now on, I'd like for you to put your names on all your programs. Most of y'all are already doing it. Just, it's good practice. Okay. Now I want to define the function. The function is going to ask the user to enter a number. How do I define a function? With the def keyword? Define def ask. We're going to print the message, enter a number. Whoops, yeah, that's right. We're going to get the value, a is equal to input, and then we're going to turn that number into an integer. A is equal to INTA. Then we're going to return it, because if we don't return it, then the code that uses the ask function won't be able to get that value and use it. So now we've written a function. Now let's use it. I'm going to put a little bit of code there, a comment that says that this is our main code. We know that it's the main code because it's the first code that's not indented. Now our secret number is going to be whatever number you want. I'm going to make mine 256. Let me eyeball my code for this one because there's always more than one way to do this, and I want to make sure. Okay, that's a good way of doing it. Perhaps not the best, but it'll work. Okay, and then our guess, which I'm just going to call G rather than type guess equals time, is equal to ask. We ask the user for their number. And while the guess is not equal, remember there's no space between the exclamation mark and the equal sign. While the guess is not equal to the secret number, we're going to tell them that they're wrong. Actually, we're going to do more than that. We're going to tell them if they're too high or too low. I'm going to erase that print statement. If the guess is greater than the secret, we're going to print too high. Else, we're going to print too low. And I always forget to put a colon on my else. There we go. Print too low. Why didn't I need an elif here? It's okay if nobody says anything, but somebody take a stab at it if you know.
Because there's only two options.
Yeah, there's only two options. Why? Because we've already ruled out the third option. If G was equal to secret, if those two were equal, then we wouldn't even be inside the while loop, because a while statement is like an if statement. It's the gatekeeper to this block of code. We only enter this block of code if this condition is true. And since this condition is true, we know that there's no third option, which is that G is equal to secret. Okay, if it was wrong, we have to ask the user again for a new number. So G is equal to ask. Now this would be more fun if we kept track of the number of tries. But we forgot to declare a tries variable up at the top. We'll fix that in a minute. I don't want to go back up and edit code above where I am right now. But if we have to ask again, let's increase the number of attempts, called tries. And then when they finally get it right, we tell them how many tries it took. If they get it right, we print congrats. And then we're going to print how many tries it made in the simplest format equals. tries, colon, followed by tries. Now I made this one uppercase and this one lowercase. As long as this one matches the variable name, that's the one that's important, because this is a string. You know, we could enter any string in here. We could put Frodo, you know, in there. And then we're done. That's good enough. Alrighty. Now, in order for this code to work, I have to initialize a tries variable outside of the while loop, because you have to initialize it before you can use it. You have to declare it. So up here above the line that says secret equals 256, I'm going to add one more line, which is tries is equal to 0. I had to add this, so I'm going to mark it really prominently. Enter a number, 200, too low. Enter a number, 300, too high. Enter a number, 256, congrats. That says it took only 2 guesses. I guess we really did 3. Oh, we should initialize tries to 1 rather than 0 for that counter to be accurate. Now, to make this a good and proper guessing game, the secret number should be randomly determined. And we can make that change, but for flowcharting purposes, I think this is enough. The purpose of this flowchart is going to be to show you how to flowchart something that has a function that we define. But I want to make sure that everybody's got it to run before I run lickety split drawing another flowchart. And then the syntax error. Yours is working?
Yeah.
Ooh, A equals INT. I've made way worse typos. 300, whatever. Try the correct number. Cool deal. So G is greater than secret. Colon. Print too high. Oh, because we're only asking if it's too low. Why are we only asking if it's too low? Because that's, I mean, it's not too low. Having it part of the block says too low. Yeah, it's not working. Sorry, I covered it up. I'm going to print this out. So now we're going to flowchart this. The interesting twist in flowcharting this, besides there's two key things that we're going to learn how to flowchart. One is how to define a function in a flowchart, or how to denote, I should say. And the other one is a while loop. And a while loop is just a decision block, but instead of the word if in it, I'm going to put the word while. And instead of it going straight down to the bottom when it's done, it's going to loop back up, each time it needs to repeat. So I'm going to make a new chart. I'm going to save this one that I did. And then do File New. And it comes up with a billion different ones. Eventually you spot the one that says blank flowchart. Okay, I would kind of like this, and at least at first, this to be on the same page. Now I'm going to put the function on the left side. The reason I'm going to put the function on the left side, well, it's personal taste, but you'll see. So on the left half of your piece of paper, you need a pill shape to start it off, but it's not going to say start. Hey, look, mine's doing the same thing now. It's putting those blocks. Instead of just putting start, I'm going to put the function name. Or maybe even DEF ask. And then these three statements should be pretty easy. Print, do an input, do a conversion. A conversion is not input-output, so it won't be in a parallelogram, it'll just be in a square rectangle. Alrighty. So I'm going to need two of these, one for the print statement, one for the input statement. Then I'm going to need a conversion statement, which is just a straight square block. And then I need a return statement, which is another pill shape at the bottom. So since this is a function, it starts with DEF and it ends with return. And in this case, we're returning a value. We're returning A. Okay, I just did all that to kind of space it out. I actually need to fill this stuff in. This one says print, enter a number. This one says A is equal to input. Or if you feel like writing it more English-like, you could just put input space A. I'm making it more match the Python code. Either way is acceptable. And this one needs to convert it. A equals int A. That does our conversion to an integer. And then lastly, our pill shape. So that's our function. Now we're going to write the main code, the flowchart for the main code that actually uses that function. And you zoom in and out with the control key. If you hold control and spin the mouse one way, you zoom way out. If you hold control and zoom in with the mouse wheel. So the main code, what I have right here, I'm going to put on the left half of the box, and that's just personal taste, but maybe it'll make sense when you look at it why I do that. It's not strictly necessary to do it that way. So the main code, I'm going to put a start pill up at the top of it and a stop pill at the bottom, just to follow standard flowcharting techniques. Why didn't we do that for the other one? Because this is a function, and you have to define the function, and then you have to say what it returns. So this is a specialized sub flowchart, which has specialized rules for what goes into the ovals at the top and the bottom. And I suppose I could put, some word like main over here, but I'm not going to do that. Okay, so here we go. Start. And we do several things. We initialize a variable called tries to 0, and then we pick a number for our secret number, and then we ask for the input. I'm going to stick 2 of those statements in a process block because they're assignments, they're math. So tries is equal to 1, and then I hit Control Enter in order to get it to the next line. And then secret number is equal to 256. Now we need to ask them for their guess. This is a special block. You'd think that since we're asking the users for a guess, we'd use the tilted parallelogram, but instead we're calling a predefined function. A predefined function, a predefined process, is another vertical box, vertical rectangle, but it's got the bars going up and down the sides. Visio has that symbol, right? Does it have the rectangle with the bars going up and down, or are you using Lucid now?
I'm using one called draw.io.
Okay.
It's just like Lucid.
Okay, cool. All right, so here we go. G is equal to ask. That shows that we're calling this function over here that we wrote. We don't normally do this for function calls, but if it's a function we wrote and that we have flowcharted, then we do put the special lines around it. Now you may be tempted to draw a line over to here and back over to here, but you don't have to do that. That's implied. That's implied by the vertical bars. One thing I do tend to do, though, is to actually color code these. And the way I do that is there's a little paint bucket. You don't have to color code this because if you choose the themes, it's going to erase it. But I tend to stick with black and white. And so I do color code it just to indicate, because I may have more than one function that I'm going to draw, and make it really clear so my eyeball snaps right over there when I see the blue one. And of course I should have lines hooking all this stuff up. And you don't have to squeeze them together as tightly as I do. Okay, now we have a while loop. We've got our guess. We're going to keep looping until G is equal to our secret number. So to denote that this is a while rather than an if, I'm going to put the word while there. While G is not equal to secret. There's going to be 2 lines leading from it. One is just going to go straight down, and another one is going to veer off to the right, just like we intended the code. If we veer off to the right, we print a message, but that message differs based on whether G is greater than secret or less than secret. First, I check if it's greater than secret, and then I have an else. So here we go. From here, I'm going to rocket off to another block. If G is greater than secret, then I print too high. Else I print too low. I think this time I'm not going to worry about making them right angles. I'm just going to leave them curves. They're clear enough. The only exception may be when I want it to go back up to the while box. we'll see how we're going to handle that. Okay. Then, what's the next line of code after those two? After the if and the else. I'm going to change that no to else. I go back and look at my code. After the two low, we ask them again and we increment the tries counter. So we're going to call G is equal to ask again. I'm going to cheat and just copy that. So I select my box here and I do Control C, which copies. And then I do Control V, which pastes. But you can also just, draw it again. It's just going to save me a little bit of time. And we need to increment tries. Now any math like that is done in a rectangle rather than a tilted box. So tries plus equals 1. Now we're going to loop. Two ways I could draw the loop. I'm going to demonstrate both of them. One is like this, going like that. Now that line went all the way through it. I could fix that. I could turn it into a right angle line. There's several ways I could fix that, but I'm going to try another line. Instead, I'm going to try to squirm this up like that and see if it looks better. No, it really doesn't. So I'm going to turn that into a right angle line. How do you turn that into a right angle line? Next to the pin, there's this little curve that says Edit Line Type. So I'm going to choose Edit Line Type and choose Right Angle. And that just shows that my while loop is over. And this is all the code that's indented under the while loop. If I go back and I compare it to my source code, like this, you'll see that all that code is indented. While G is not equal to secret. If G is equal to secret, there's that. Print too high, else print too low. And then G is equal to ask, and then tries is equal to 1. Now we're done with our indented code, so we're back down here. So now I need a line that just goes straight down to the bottom and prints, how many guesses it took. I'm going to make that kind of veer off to the side, though, just to try to get it more on one page. Normally I wouldn't do that. Normally I would put it down here. And maybe as a final thing, before I close my document, I'll do that. Okay, so what do we do at the very end? What's the next thing after the while loop? Somebody tell me. Pop open your code again and tell me what the next... Pardon me?
Print congrats.
Okay, print congrats and then print out the number of tries.
Yeah.
Okay, so print congrats. And then print the number of tries. And then we're done. So I'm going to put a stop block, a stop oval. So that's what my flowchart looks like. Amazingly, I got it to fit on the screen. I'm not sure if you can read all the writing. Hopefully you can. There we go. Now the last thing I would do if I was drawing this for my own edification and I wasn't being insistent upon it fitting on one page is I would grab these three boxes and I would put it down here underneath the rest of the code. The only reason I tend to do that is because, all of this is indented and then the indentation stops and that makes it look structured similarly to the way the code is structured in the document. However, the flowchart doesn't have to look like the code because they are really two very different things. One is a logic map and the other is, the statements that actually run it. Okay, So what's the takeaway on this? A while statement looks like an if statement, except there's no else. I promise that if I give you a flowchart that has a while loop here, then some people are going to put an else statement after the while loop. There's no such thing as an else on a while. That's why I don't put the word else there. You know, if I go back and I look at my code, all it is while. There's no else statement. Once it's done with the while loop, it just continues execution right there. Since it is a while loop, instead of an if statement, I actually put the word while there. To define a function, I do it like this. This is a predefined process. Process and function being synonyms as far as flowcharting is concerned. And so to define my function, I put the name of the function up at the top. I put a return statement down at the bottom, along with what value it returns if it's a fruitful function. If it's a void function, you don't have to put anything there. And then when I call it, I put it inside a rectangle with the bars, like that. Coloring is optional. Alright, I didn't have you save the other one. But we need something to put in the Dropbox we're going to make, so we may as well save this one. And if you want to save the other one too, that's fine. You'll probably just have to go back and open it again. When I say save, I mean save as a PDF, which is actually the print statement. So I'm going to choose File, Save, or Save As, give it a good name. This is the Guessing Game 2 flowchart. And then when I'm ready to save it as a PDF, I come up under the File menu and say Print. Or maybe Download. What would Download save it as? Oh, cool. You can download it as a whole bunch of different formats. Choose Download. That's way better. Okay. So do File, Download, Download As, and you can pick what format. PDF is cool, but I can take it as a PNG, you know, or a JPEG. John might like the Vizio. No. So anyways, there we go. I'm going to download the PDF. It's not going to give me, ooh, it even gave me a chance to pick its name. I'm going to save mine to the desktop, and then I'm going to upload it into the Dropbox, which I will create. Let me create the Dropbox, and I'm going to wander around and make sure everybody's doing okay. We're going to iteration, which is chapter 7. And here's what he has to say about it. Computers are often used to automate repetitive tasks. Repeating identical or similar tasks without making errors is something that computers are exceptionally good at, and people do poorly. So like in the 1700s and 1800s, you know, before people had mechanical calculators or anything like that, in order for scientists and mathematicians to multiply and divide large numbers, you know, suppose you had to divide 3,471 by 2,892. You know, that's long division, and that takes an incredible amount of time to do accurately. However, you can approximate it very quickly by using logarithms. You take the logarithm of 3 billion, whatever that number was, you take the logarithm of the 2,700 number, you subtract the 2, and then you look up what the logarithm of that result is, back on the table, and you will see the result, and it'll be pretty close. It might be close enough for your purposes. Now, creating these books full of logarithms for every number between 1, you know, and 100,000 or something like that takes an incredible amount of time. Some poor scribe, you know, sitting there performing that calculation, filling books full of tables, and he had lots of errors in it, you know, the people who would make these. And that's just one example. So people wanted to make a machine that could repeat a calculation over and over and over. And that's just one of them, so that you could perform the calculation and you could record it in the table. You could perform the next calculation and put it into the table, you know, the book that you're writing. And that's called iterating. Iterating is repeating a task over and over. Because iteration is so common, Python provides several language features, specifically the while loop and the for loop, to make that easier. We've already seen for, or at least it says we have. This is the form of the iteration you'll likely be using most often. I'm not sure about that. I use while an awful lot. In this chapter, we're going to be looking at the while statement. It's another way to have your program do iteration. Our program sampled while. It gave an example of while. So we need a concept. The concept of assigning a variable is when you use the equal sign to copy a value into the variable. Here they have one. Airtime remaining is equal to 15. That assigns the value of airtime. It copies 15 into that variable. Airtime remaining is equal to 7. That copies that value into that. But you can also do what's known as an update. You can take a variable and modify its value. We were doing that with that tries plus equals 1. It actually modified the value of the tries variable. So here's an update. N is equal to 5, and then we're going to update the value of it. N is equal to 3 times n plus 1. So n is going to change value based on what it was before. What is 3 times n plus 1 here? If n was equal to 5 before it executed. 16. So after these two lines of code execute, n is now equal to 16. Why are we focusing on the idea of updating? Because very typically in a variable, in a loop, you are updating the value of some variable. Whether you're doing it mathematically here, or whether you're asking the user for new input, like we did with our guests. You will be continually asking or calculating a new value for a variable. You will be updating it. And that's a good place to stop.